The universe is full of wonders, places and objects so strange they stretch the limits of our imagination. Recently, with its powerful golden eye, the James Webb Space Telescope peered into the darkness and found something truly mind-boggling. It discovered a planet unlike any we have ever seen before, a world orbiting a special, violent star. Scientists named this planet PSR J2322-2650b, but its story is far more exciting than its name. This isn't a friendly, Earth-like world. Instead, it's a survivor, a witness to one of the most extreme processes in the cosmos. And its atmosphere holds a secret that is making astronomers rethink everything they thought they knew about how planets are born. So, what kind of star does this strange planet orbit? It circles a pulsar, which is the super-dense, spinning core left behind after a massive star explodes. Think of it as a cosmic lighthouse, sweeping beams of intense radiation across space as it spins hundreds of times per second. But this isn't just any pulsar. It's a special kind known as a black widow. Just like the spider, this pulsar is a predator. It has a companion star that got a little too close, and the pulsar's immense gravity and fierce radiation are slowly tearing its partner apart, stripping away its outer layers piece by piece, like a spider consuming its mate. This cosmic drama is the birthplace of our mysterious planet. The object we see today, PSR J2322-2650b, is not a planet that formed in the usual gentle way from a disk of gas and dust. Instead, it is the leftover core of the star that the Black Widow pulsar has been feasting on for millions of years. The pulsar has stripped away almost everything, leaving behind a dense, hot object about the size of Jupiter. This survivor now orbits its destructive partner at an incredible speed, completing a full year in just under 8 hours. It's trapped in a gravitational dance of death, forever tied to the star that destroyed it. What makes this cosmic remnant so astonishing is what the James Webb Space Telescope found in its atmosphere. When scientists pointed the telescope at this world, they expected to find an atmosphere made of light elements like hydrogen or helium, the typical stuff stars are made of. But the light that came back told a completely different and utterly baffling story. Instead of the expected gases, the telescope detected the unmistakable signature of carbon. Not just a little bit of carbon, but an atmosphere made almost entirely of it. It's a world of pure carbon, something that shouldn't exist according to our current theories of the universe. How could such a bizarre world come to be? Scientists are still trying to figure that out. The leading idea is that the planet we see today is the heart of what was once a normal star. This star was born with a partner, the star that would eventually become the pulsar. When its partner exploded and became a pulsar, the survivor star was caught in its powerful gravitational pull. For eons, the pulsar has been siphoning off the lighter elements, hydrogen and helium, from its companion's atmosphere. This process slowly whittled the star down, leaving behind only its dense, heavier core, a process of stellar transformation that is both violent and creative. This stripping process is what makes the planet's atmosphere so unique. As the pulsar pulled away the lighter gases, it exposed the star's inner layers, where heavier elements were forged. In the intense heat and pressure deep inside a star, simple elements like hydrogen and helium are cooked into heavier ones, like carbon and oxygen. The star that became PSR J2322-2650b was likely rich in carbon at its center. When the outer layers were gone, this carbon core was all that remained. The pulsar's intense radiation then heated this core, boiling the carbon off into a thick, exotic atmosphere. This is not how planets are supposed to get their air. The result is a planet with an atmosphere that is truly alien. On Earth, our atmosphere is mostly nitrogen and oxygen. Even gas giants like Jupiter are made primarily of hydrogen and helium. But on this world, the air itself is composed of molecules like dicarbon and tricarbon. These are forms of carbon you might find in the tail of a comet or in the flickering flame of a candle, but never as the main component of a planetary atmosphere. The carbon-to-oxygen ratio on this world is over 100, while on Earth, it's a tiny fraction. It's a chemical composition that breaks all the rules we've come to expect. Imagine standing on a surface that could see this sky. You wouldn't see a familiar blue, or even a hazy orange. You would be looking up into an atmosphere of pure soot. It's a testament to the extreme and varied environments the universe can create. This planet is not just a curiosity, it's a natural laboratory. It's showing us that the leftover cores of stars can evolve into planet-like objects with chemistries that we never predicted. The discovery forces us to expand our definition of what a planet can be and how one can form in the chaotic aftermath of a star's life and death. Because this carbon planet is so close to its pulsar, it is tidally locked. This means the same side of the planet always faces the star, just like the same side of our moon always faces Earth. This creates a world of two extremes, a permanent day side and a permanent night side. The day side is locked in a perpetual bath of intense radiation from the pulsar, roasting it at temperatures above 2000 degrees Celsius. In this incredible heat, the carbon atmosphere glows, allowing the James Webb Telescope to see its chemical makeup clearly. It's a landscape of unimaginable heat, a glowing ember in the dark. The night side, forever turned away from the pulsar's glare, tells a different story. When the telescope looked at the dark side of the planet, it saw almost nothing. The spectral signals nearly disappeared completely. Scientists believe this side is so dark because the carbon in the atmosphere cools and condenses into a thick black substance, perhaps something like soot or tar. This material might rain down onto the surface, coating the entire night side in a layer of non-reflective blackness. It's a world divided, with one half glowing brightly, and the other half shrouded in an impenetrable, carbon-rich darkness. It's a stark contrast between a brilliant furnace and an eternal dark void. But the telescope found something else hidden in the planet's atmosphere: wind. We can't see the wind directly, but we can see its effect. The hottest point on the planet wasn't directly facing the pulsar as you might expect. Instead, it was shifted slightly to the west. This tells scientists that powerful winds are blowing across the planet, carrying the immense heat from the day side around toward the night side. These winds are likely moving at supersonic speeds, creating a global weather system unlike anything in our solar system. This is the first time we've seen this specific wind pattern on such a rapidly rotating, tidally locked world. This discovery of westerly winds is exciting because it confirms a long-held scientific prediction. On other hot, Jupiter-like planets that rotate more slowly, the winds tend to blow eastward. But theorists predicted that on a fast-spinning planet like this one, the winds should blow in the opposite direction, to the west. And that is exactly what the James Webb Telescope found. So, while the planet's carbon atmosphere was a complete shock, its windy weather was something scientists were hoping to see. It's a strange mix of the totally unexpected and the beautifully confirmed, a perfect puzzle for astronomers to solve. The discovery of this carbon planet, PSR J2322-2650b, is more than just finding another strange world. It's a direct challenge to our understanding of how planets form and exist. The models that scientists use to predict what kind of planets should be out there simply do not have a category for this object. Our theories of planet formation are based on what we see in our solar system and the thousands of other exoplanets we've found so far. They usually start with a disk of gas and dust around a young star, where water, silicates, and other common materials clump together. This carbon world doesn't fit that story at all. This isn't the only recent discovery from the James Webb Telescope that points to carbon playing a bigger role in the cosmos than we thought. In another part of the sky, the telescope looked at a stellar nursery, a place where new planets are just beginning to form. There, too, it found a surprising amount of carbon-based molecules and a strange lack of water, which we always believed was a key ingredient for planet formation. These two discoveries, a fully formed carbon planet and a carbon-rich planet nursery, suggest that there may be a whole class of carbon-dominant worlds out there, formed under extreme conditions that we are only just beginning to understand. For scientists, a discovery like this is the best kind of problem to have. When observations don't fit the theories, it doesn't mean science is wrong. It means there is something new and exciting to learn. It means the universe is more clever, more varied, and more surprising than we had imagined. The existence of a planet made of carbon, born from the death of a star, forces astronomers back to the drawing board. They must now ask new questions. How common are these black widow systems? Can other types of stars produce carbon planets? What other strange chemistries might be possible in the universe? The cosmos has thrown us a curveball, and that's the beauty of scientific exploration. Every time we build a new tool like the James Webb Space Telescope and point it at the sky, we learn that our cosmic neighborhood is filled with more marvels than we ever dreamed. The story of this windy, two-faced, carbon-rich world is just beginning. As we continue to study it, we will undoubtedly learn more about the violent and creative forces that shape planets. We are on a journey of discovery, and the universe has once again reminded us that there are always more secrets waiting to be uncovered, just beyond the edge of our knowledge.